Welcome to Scienceado Tech Update. James Webb Space Telescope. Everything you need to know. The James Webb Space Telescope, JWST, is the largest and most powerful space telescope to date. NASA's Infrared Space Observatory, launched on December 25, 2021, from ESA's launch site at Kourou in French Guiana, at 7:20 a.m. Eastern Standard Time, 12:20 GMT, 9:20 a.m. local time in Kourou, aboard an Arianespace Ariane 5 rocket. The $10 billion James Webb Space Telescope is probing the cosmos to uncover the history of the universe from the Big Bang to exoplanet formation and beyond. It is one of NASA's great observatories, huge space instruments that include the likes of the Hubble Space Telescope that peer deep into the universe. It took 30 days for the James Webb Space Telescope to travel nearly 1 million miles, 1.5 million kilometers, to its permanent home, Lagrange Point 2, a gravitationally stable location in space. The telescope arrived at L2, the second Sun-Earth Lagrange point, on January 24, 2022. L2 is a spot in space near Earth that lies opposite the Sun. This orbit allows the telescope to stay in line with Earth as it orbits the Sun. It has been a popular spot for several other space telescopes, including the Herschel Space Telescope and the Planck Space Observatory. According to NASA, the James Webb Space Telescope will focus on 4 main areas: the first light in the universe, the assembly of galaxies in the early universe, the birth of stars and protoplanetary systems, and planets, including the origins of life. On July 11, 2022, NASA announced that all 17 of the observatory scientific instrument modes had been fully vetted and that the James Webb Space Telescope was ready to begin its epic science mission. The powerful James Webb Space Telescope is taking amazing photos of celestial objects like its predecessor, the Hubble Space Telescope. Luckily for astronomers, the Hubble Space Telescope remains in good health and the two telescopes will work together for JWST's first years. JWST will also look at exoplanets previously identified by the Kepler Space Telescope and follow up on real-time observations from ground space telescopes. The James Webb Space Telescope is the product of an impressive international collaboration between NASA, the European Space Agency, ESA, and the Canadian Space Agency. According to NASA, the JWST involved over 300 universities, organizations and companies across 29 U.S. states and 14 countries. James Webb Space Telescope launch and deployment. Since its launch, the James Webb Space Telescope's accomplishments just keep on coming. An impressive HD video captured the observatory flying away from the Ariane 5 rocket that carried it into space. The 3-minute video shows Webb slowly drifting away from its rocket stage and unfurling its solar panels. The JWST deployed and tested a key antenna on December 26, 2021, in a process that took about 1 hour. According to a NASA statement, the antenna will be responsible for twice daily science data dumps to Earth. Just a day later, on December 27, the observatory sailed beyond the orbit of the Moon. On December 31, 2021, Webb successfully unfurled its massive sunshield. The tensioning of the sunshield's 5 layers began on Jan 3, 2022 and was completed the next day. The telescope's secondary mirror was then successfully deployed and latched on January 5, 2022. Then on Jan 8, 2022, NASA announced that the James Webb Space Telescope had successfully unfolded the giant primary mirror and is now fully deployed. The next step for Webb is the alignment of the 18 individual mirrors that make up the observatory's primary mirror. NASA estimates the work could take up to 120 days after launch for the alignment to be complete. The James Webb Space Telescope reached its final destination, L2, the second Sun-Earth Lagrange point, which it will orbit on Jan 24, 2022 after traveling nearly 1 million miles, 1.5 million kilometers. The James Webb Space Telescope's first science images were officially released by NASA during a live event on July 12, at 10:30 a.m. Eastern Daylight Saving Time, 14:30 GMT. They included the cosmic cliffs in the Carina Nebula, the striking Southern Ring Nebula, Stephan's Quintet, and an analysis of the atmospheric composition of the hot gas giant exoplanet WASP 96b. A day earlier, on July 11, 2022, President Joe Biden, Vice President Kamala Harris and NASA Administrator Bill Nelson unveiled the first science quality image captured by the James Webb Space Telescope. The stunning image shows the deepest infrared view of the universe to date, according to a NASA statement, and was created using just 12.5 hours of observing time on one of the telescope's 4 instruments. On February 11, NASA announced that the James Webb Space Telescope had captured its first images of starlight. The first image taken by Webb was of a star called HD 84406. Light from HD 84406 was captured by Webb's 18 mirror segments located on the primary mirror, resulting in a mosaic of 18 scattered bright dots. As Webb aligns and focuses over the next few months, these 18 dots will slowly become a single star. Thomas Zurbuchen, NASA's Associate Administrator for the Science Mission Directorate, said on Twitter on February 18. NASA released a new and improved image of HD 84406, bringing 18 unfocused copies of a star into a deliberate hexagonal formation. Once the observatory has successfully aligned the individual segments of the primary mirror, it will begin the image stacking process. This will bring 18 images on top of each other into one clear view. Webb has also taken an impressive selfie using a specialized camera inside the NIRCam instrument. The camera is designed to be used for engineering and alignment purposes. In the selfie, you can see one of the mirror segments as shining brighter than the others. This is because it is the only segment at the time successfully aligned and pointing at a star. The rest of the mirror segments were successfully aligned one by one. On April 28, NASA announced in a statement that the James Webb Space Telescope had finished its alignment phase after demonstrating it can capture crisp, well-focused images, with all 4 of its scientific instruments. On July 11, 2022, President Joe Biden, Vice President Kamala Harris and NASA Administrator Bill Nelson unveiled the first science quality image captured by the James Webb Space Telescope. The stunning image shows the deepest infrared view of the universe to date, according to a NASA statement, and was created using just 12.5 hours of observing time on one of the telescope's 4 instruments. James Webb Space Telescope Science Mandate. JWST's science mandate is principally divided into 4 areas. First, light and reionization. This refers to the early stages of the universe after the Big Bang started the universe as we know it today. In the first stages after the Big Bang, the universe was a sea of particles, such as electrons, protons and neutrons, and the light was not visible until the universe cooled enough for these particles to begin combining. Another thing JWST will study is what happened after the first stars formed. This era is called the epoch of reionization, because it refers to when neutral hydrogen was reionized, made to have an electric charge again, by radiation from these first stars. Assembly of galaxies. Looking at galaxies is a useful way to see how matter is organized on gigantic scales, which in turn gives us hints as to how the universe evolved. The spiral and elliptical galaxies we see today actually evolved from different shapes over billions of years, and one of JWST's goals is to look back at the earliest galaxies to better understand that evolution. Scientists are also trying to figure out how we got the variety of galaxies that are visible today, and the current ways that galaxies form and assemble. Birth of stars and protoplanetary systems. The Eagle Nebula's pillars of creation are some of the most famous birthplaces for stars. Stars come to be in clouds of gas, and as the stars grow, the radiation pressure they exert blows away the cocooning gas, which could be used again for other stars, if not too widely dispersed. However, it's difficult to see inside the gas. JWST's infrared eyes will be able to look at sources of heat, including stars that are being born in these cocoons. Planets and origins of life. The last decade has seen vast numbers of exoplanets discovered, including with NASA's planet-seeking Kepler Space Telescope. JWST's powerful sensors will be able to peer at these planets in more depth, including, in some cases, imaging their atmospheres. Understanding the atmospheres and the formation conditions for planets could help scientists better predict if certain planets are habitable or not. James Webb Space Telescope onboard instruments. The JWST is equipped with 4 science instruments that will enable observations in visible, near-infrared and mid-infrared, 0.6 to 28.5 micrometers wavelengths. James Webb Space Telescope versus Hubble Space Telescope. Scientific advancement is all about standing on the shoulders of giants, and the JWST is doing just that, as its scientific goals were motivated by the results from the Hubble Space Telescope. The two space telescopes have different capabilities. Whilst Hubble primarily observed the cosmos in optical and ultraviolet wavelengths, with some infrared capabilities. The JWST is primarily looking at the universe in infrared. Due to the expansion of the universe, light from distant objects shifts to longer wavelengths at the redder end of the spectrum, known as redshift, according to ESA. The JWST will observe this infrared light in great detail and shed light on some of the oldest stars and galaxies in the universe. Another big difference between the James Webb Space Telescope and the Hubble Space Telescope is that JWST orbits the Sun, whilst Hubble orbits Earth. JWST will be too far away to be serviced, unlike Hubble, which was accessed and serviced by space shuttle missions. James Webb Space Telescope delays. The JWST was first slated to fly in 2007, and since then astronomers' patience has been sternly tested. A mix of engineering problems, political hesitancy and project management issues have all contributed to countless delays. In July 2011, U.S. politicians threatened to pull funding for the JWST. After a nail-biting few months, the spacecraft was saved in November 2011. Then in March 2018, the launch of JWST was delayed due to technical issues with the spacecraft. Later that year in June, an independent review board recommended the launch be moved to March 2021. In 2020, the global coronavirus, COVID-19, pandemic impacted JWST's progress, and in July 2020, NASA announced a new launch date of October 31, 2021. Despite the perseverance and determination of the JWST team during a difficult time, the delays kept coming. In June 2021, problems with the Ariane 5 launch vehicle pushed the launch date back to November or possibly early December 2021. Then in September NASA and ESA announced yet another delay as the observatory had not yet been shipped from its original location in California to ESA's launch site at Kourou in French Guiana. The two agencies announced a new launch date of Dec.18, but bad weather soon put a stop to that. Finally, the JWST successfully launched on December 25, 2021, from ESA's launch site at Kourou in French Guiana. Hit the like button if you like this video and share your ideas in the comment section. And of course do subscribe.